Welcome to our podcast again. Nick
we're
Butt
here.
from U-Water, Head of Water Services, and today we have Dave Leigh, the Marketing Director from Micronics. Welcome, guys.
Morning.
Thank you very much
Hi,
for your time today. As an introduction to Dave's products, which is the wastewater meter you see here, just like to talk about as an introduction to those that are watching the podcast with regards to wastewater charging. Now, at the minute, basically it can be anything from 100%, it goes down to 90, 95 and 80%. They're basic, they're estimates, aren't they? So, and there's no real way of measuring customers except the default. And what we're looking to do is change that, and I think that's going to be a huge change in the wastewater industry per se. What say you?
Well, I think one of the changes we're going to see in the retail market is the defining of the accuracy of volumes that are used to establish allowance claims and trade effluent discharges. That's for defining what goes into the trade effluent consent as maximum flows, but also the volumes used in trade effluent charges as well. I think there's a need to actually change some of the historical, we call it gentlemen's agreements, or basis on estimates and assumptions on how allowances have been made for the non-return to sewer claims, and also the trade effluent volumes used historically, that I think the wholesale and retail companies out there want to review again to ensure that everyone is getting the correct levels of income. I think there's been a slight willingness in the past on defining those volumes, and there is now probably going to be an impetus on anyone making claims, either the renewal or new claims for allowances and trade effluent discharges, that they have to accurately measure the actual discharge to sewer. So for allowances, if you're making a non-return to sewer claim, there's often been a sort of an estimate of how much water isn't returned to sewer, and that has been related against the water input meter.
So you're basically sticking a sub-meter on the feed to that particular piece of apparatus, which essentially you're claiming an allowance against that. In the case of United Caspar recently, a big steel company in Chesterfield, we relied on the input meter on this particular process, and it was a staggering 88% non-return, and that was 40 grand a year. That's like 88% reduction in their wastewater charges, and that was just a typical example. That resulted in £150,000 worth of revenue back to the customer, and there'll be thousands of these situations out there, won't there?
But on take the other hand as well, there'll be some allowances, historical allowances, which are now in place, or new allowances have been put in place in the last couple of years, where they've been based on estimates of what isn't returned to sewer. And if meters were installed, it would actually prove that those allowances are too high,
right?
And it would generate more income for the retailer and the wholesaler. They'll be able to claw back some of the income they weren't actually charging for. So it works probably two ways, actually, for customers. They may be worse off or better off with the installation of these meters for allowance claims. And also, the same applies for trade effluent applications. You have to define what is going to be the maximum and instantaneous flow to be discharged by a trade effluent process. And that is very, very often difficult to prove, and historically has been established on I don't want to say guesstimate, but a good reasoned water balance of how water is distributed around a factory, for instance, and what would be the volume discharged to drain by the trade effluent process. And then these kind of meters will probably be required in the future to close off that inaccuracy or unknown estimate.
That'd be good for your business, Dave, because if current legislation comes in to accurately measure the outfalls or the discharges for commercial and then domestic, happy days.
Mm-hmm. Yes, indeed. No, it's I think actually as well, taking the point that Nick was making, I think that it's likely that where it's an estimate, isn't it likely, Nick, that they're more likely to be in favour of the retail companies or the original wholesale water companies? So it's more likely when you do start actually metering the discharge that it's probably going to produce savings in the direction of the user on the consumption rather than back to the retailer or the wholesaler?
I think it'll
It'll
work both ways, actually.
You think it could be just 50-50?
I don't know about 50-50, but I think it'll work both ways. But I can't say which way will benefit the most.
Yeah, I'd agree with that.
But it all comes down to defining an accurate volume. That's what it's all about, and to ensure that wholesalers and retailers are getting the correct income that they should be getting from the customer.
Absolutely.
I think from where I'm sat, really, I don't know about you guys, but from what I'm hearing from customers is we just want to pay the correct charges.
Yes.
Absolutely. They've no issue with paying because everyone's got to pay water and wastewater charges. They just want to pay the correct charges, and that really is what it's all about. So. You've got to be somewhere, so we'll let you go.
Sorry, I was going off prematurely there. I'll go now.
Sloping off.
Slowly go out of view.
Thank you very much. We're done with you.
Cheers, Nick. Thanks
Cheers,
very
Nick.
much.
See you later. Right, so Nick from U Waters departed now for Bristol or Northampton, wherever he's going.
Northampton now, yeah. See much rain.
Close it on the way out.
Thank you very much.
Cheers, Nick. Much obliged. Speak to you later. Cheers, boy. Right then. It's just you and I.
Okay. Well, I think that was a good introduction from Nick in terms of the argument of the case for using the wastewater meter.
Yeah.
We've had it in the market now for a good 2-3 years. It's actually quite a unique product in it. It works on a gravity-fed sewer basis. Mm-hmm. Okay. So as you can see here, this meter is really just an extension to the sewer pipe. You see my hand there going, can see waves?
Oh, God, yeah.
All right. Okay.
Nice smooth transition of waste.
You know the sort of things that go down waste pipes.
Yeah.
So you're not going to have a problem of things getting stuck and it being blocked. If it does, it can be easily flushed out.
Yeah.
Okay.
Yeah.
So that's a good reason to have that there.
Moving on.
But but we've had a number of examples where it's been used in process applications like cake manufacturers and laundry applications.
What sort of savings have we seen there then?
Well, we've been seeing savings with payback in well under 3 years.
Wow, that's good.
Okay, so that's really what you're looking at. Because if you've got a freshwater bill, incoming water bill of in excess of £15,000 a year, and the estimates, they vary, as you know, from water utility to water utility or retailer to retailer, but it can be anything from 90% sort of to 80%, that sort of area. Then there's a possibility you might be they may be out by 10 or 20%.
Right.
Okay. Yeah. So if you're looking at a bill of £15,000 a year or more, then you could be looking at anything from £1,500 to £3,000 saving by moving from being paid or being charged rather specifically on the amount of waste that's going out as opposed to an estimate.
So £15,000 in water, wastewater is normally 2, 3, 4 times more.
Yeah.
So let's not forget the waste. So it's £15,000 water bill.
Yeah.
And the wastewater could be 3 times that.
Absolutely.
40, 50 grand a year.
So you might say, well, sorry, why should it be wrong? Why should this estimate be wrong? Well, when you make an estimate, you're going to obviously take into account some calculations on. These estimates could be quite old. They may not take into account deficiencies and changes in the factory or the process and so on and so forth. So,
or just lack of knowledge on behalf of the customer.
Lack of knowledge maybe on behalf of the customer.
Yeah. That's where we come in.
You know, I remember talking to you not that long ago about we were saying, well, you know, the process could be using the water in terms of evaporation or whatever. Okay. So it's not all, that's something that's not going down the discharge, as it were, or it could be going into the production process itself. But then you, of course, brought out one which was really quite a key one, which is if you're actually paying your discharge water bill as a percentage of your incoming water bill, okay, your wastewater bill as a percentage of your incoming water bill estimated, if your incoming water bill is exceptionally high because you've got a leak, that's going to reflect on your discharge.
That's right, because your water's actually going into the ground, not into the sewer.
Yeah, absolutely.
So if you can locate the foul sewer discharge and put these guys on,
absolutely.
So you've got, 50,000 cubic metres of water going in, and you've got a 30% leak, which is not out the way for a leisure site. Likes of Bourne Leisure and Park Dean and all these sorts of large companies have issues, which they're obviously addressing. But and other smaller independent operators, I would suggest, we reckon 20 to 30% leakage across 10, 15, 20,000 different fittings underground. There's no way that you can secure a network like that. Oh. But if you can identify the sewer outfalls and put these guys on, if you've got 50,000 cubic metres of water going in the main water and 30% less, 15,000 less going out in waste, Bob's your uncle. You can apply to the water company and say, hang on a minute, I've got my water in measured, I've got my water out measured as waste, I've got leakage, you should be charging me based on what I actually discharge as opposed to what you're doing on the bill.
Absolutely.
And that is massive.
Absolutely. And when we've spent a lot of time in the last 18 months sort of doing research of the marketplace, talking to potential end users of this type of product and so on. And quite often the initial reaction is great. Wow, I can actually meter my discharge. Fantastic. But then, of course, when you're putting in any new product, there's an investment associated with it. And when you look at the cost of the investment of going in, they're saying, well, I don't know whether I've got the actual experience to be able to make that investment judgment. Okay? And so that, of course, brings you into play, and it brings Nick into play, because, of course, you guys do have the experience and the knowledge to be able to say with confidence, this will happen because we know how the water's circulating in the building, the process, and so on, and how it'll come about.
This fits in quite nicely, actually, with an additional market, which you probably realise, water retailers out there, which is 24, 25 water retailers or added value services.
Yes,
they ought to be looking at this boy. Yeah, because if they can identify those customers that their bills are 50, 60, 70, 80,000 pounds a year, and there's potential for measuring their wastewater out, I would suggest that customers would far prefer to go to a water retailer who's levying accurate charges both in water and waste, as opposed to an estimate. And that could be a real big tick in the box.
Absolutely.
For water retailers, couldn't it?
Because of course, retailers are working on very tight margins.
Yeah, absolutely.
They've just been given part of the overall water distribution profit that's available there, and if you look at one retailer against another, they've got very little scope to actually move the price up and down. So, of course, they need to differentiate themselves. Yeah. And as I know in previous podcasts you've done with people like Nick and so on, it's come out that that differentiation comes from introducing added value services. Yeah. And, of course, the metering and giving more information and being able to improve the customer service comes into play.
If you can't meter it, you can't measure it, you can't reduce it.
Absolutely. That's exactly it. That's our logo for Micronics. Through measurement comes control.
That's right. Absolutely.
And you need to know what's flowing where. This is at the back end, shall we say? Okay.
So will water companies set this as an accurate form of measurement for billing?
They have to under their franchise, the way it's actually set up. If there is a better way of actually determining the actual value of discharged water.
It's certified, isn't it?
It is certified.
Well, can you tell us more about that?
It's got MCerts.
MCerts?
Yeah, MCerts is a measurement certification body set up by the government, and where you've got what you might call fiscal applications, where people are looking to have a certain degree of accuracy because they need to be able to bill against it. Okay, then we bring in organisations that can actually do an M certification on the product. And that will then give you, what that means is, in essence, is that they take the product and they write a test specification for it. Having written a test specification, you then get a period of about 18 months where it's really thoroughly tested.
I know, because I said, has it got the appropriate qualification? Yeah. Yes, it has. Yeah. Well, why didn't you have it before? It's taken us bloody 2 years.
Yeah, absolutely.
That's a long process, isn't it?
It's a very long, not only a long process, but a very expensive process. But what comes out at the end is it basically is something that then the end user can rely on, right, in terms of the confidence to make the investment that this will work, and also that the water retailers and the water companies can have the confidence that if they're going to be giving money back, that they're giving it back according to an accurate measurement.
Absolutely,
okay? So that actually pins that down.
We could probably, with these podcasts, it's informative and educating the industry, which is the idea behind them. And it's working really well because we're getting a hell of a lot of traction. And there is enormous interest on the waste aspect. From an environmental point of view, we've got this huge movement towards getting rid of plastic, recycling waste and reducing carbon. A big contribution to carbon is the rubbish that we chuck down the drains, and I'm amazed it's not measured accurately, so that water companies can determine exactly where all the waste is going and in what volumes, and it's just simply not.
No.
So the value of this is tremendous. I think once you've identified the need, that's the point, isn't it? So identifying the need, picking the right customer, who's got a decent sized bill. If you've got a trade effluent consent, you should have one of these as per your consent.
Yeah.
I'm seeing more and more companies haven't got them.
Yeah.
They're just relying on the input, and it's a guess as to where all the water's going. The waste goes out, and the water company will go, "Oh yes, you've discharged 50,000 cubic meters at £4, £5 or £6 a cubic meter, £200,000-300,000 bill," and the chief engineers accepted it because they haven't got any form of measure. You quantify that, and away you go.
Yeah. So there's really two applications to reiterate this.
Right.
One is the claim back of non-return to sewer charges
and continual accurate billing going forward. Yeah,
that's one.
Yeah.
And the other one, of course, is compliance. Being able to demonstrate compliance with effluent license monitoring.
Absolutely.
Now, at the moment, or previously, what you've been looking at in that area is that you might have to put in a weir or a V-notch weir or whatever. Very expensive, very high maintenance, ongoing maintenance costs.
They clog up.
They get clog up and so on and so forth. Okay. This, by comparison, for looking at an installed comparison, you're looking at probably 50% of putting in a weir and so on and so forth. But the added thing from the ongoing maintenance point of view is, of course, that nothing gets stuck. Because as we mentioned earlier on, okay, you can see the hand there, clocked at 8. Okay. That, which means, of course, if you do have a problem, all you have to do is flush it down. Excuse the pun again.
That's quite all right. I'm used to them now, Dave. I've known you how many years?
So I think there's a potential opportunity for significant potential opportunity for it. But it's just a matter of getting the message out there, as you say, Graham, and getting people to, to take it on board and find the right way for it to go in. And I think that the right way to take it to market is actually as part of a holistic approach to water on a site. So looking from the water in to the water usage on the site to the waste.
We all talk about water conservation.
Yeah.
But the more water you use, the more waste you discharge. Yeah. So it's kind of like £1 a cubic metre, £1.20 cubic metre water for water, and the waste could be £2 or £3, or trade effluent. I've seen trade effluent bills of 10, 11, and £13 a cubic metre, and it's not measured. No. And you think, well, you accept the measurement from the water meter because that's a statutory requirement. These really ought to be a statutory requirement.
And to be fair, in this day and age, we should be metering everything.
Absolutely,
the technology's there to do it. This is, I believe, actually a unique product in that respect. It's the only product that has no insert in the pipeline, as it were.
Nothing to go wrong, really, because all the workings is in there.
I mean, there are other. This is a gravity feed sort of goes on a gravity feed sewer, so you're measuring the flow, anything from 3 millimeters right the way up to nearly full on the sewer. But if you put the other alternative you could put in there would be like a area velocity meter. And if you're going to put that in, you've got to put something actually in the flow.
Right, yeah.
So
a mechanical device.
So
and all the problems you get with those.
They're not saying they don't work, but there's a potential that you're going to have ongoing maintenance problems and so on.
Agreed.
So that's where that comes from.
I don't want the chief engineer on your back saying, install this gear, it saved me a fortune, but I'm spending it now on maintenance because it keeps clogging up. It's a really slimline design. I've seen it in a concrete chamber. It really does look the business.
That's the bit. That's the bit that goes in the ground. Okay. The other bit.
So you can actually get the flow and
it actually connects
online
to a box. Okay, a RAS unit. And this RAS unit then connects online. All right. So you basically have a dashboard, and in that dashboard, it will give you all the information about your instantaneous flow, your totalized flow, what's happening basically in your sewer. All right. If you get a high level alarm, it will tell you about it, and so on and so forth, going down, low level and so on. All the information is there, and that information can be accessed from basically anywhere that you've got access to the internet.
That is fantastic because from a perspective of H2O's clients, new and existing, we're data logging the input, we're not data logging the output.
Yeah.
If you've got those on a site,
Yeah.
that is a very, very powerful water management tool.
Yeah.
You can really then drill down exactly where everything's going.
Absolutely.
And get a grip on your costs.
And in terms of it being a tool, in addition to the monitoring, what of course it also enables you to do is, because you can see exactly what the level of flow is, it means you can do much more. If you're going to need to do sampling of the effluent as part of your discharge license, there's an optimum time to actually sample the effluent at certain flow rates. What this will do is that you can actually set it up to trigger an automatic flow measurement, analysis measurement at a certain flow rate.
Right, wow.
Okay, so that means that you're getting a better representative of what the actual quality or content of the discharge that's going out, as well as the flow at the same time.
Because they're talking about now, there's a lot of talk in the media, comes across my computer, these new online water flow data loggers with built-in AMR, automatic meter reading, and you can trace the data online. It's exactly this.
This is what this is.
Yeah. I mean, why we're not doing it? Why more aren't doing it? I hope, as a subject to this podcast, that more people get on board. So how does it measure because it's got nothing in there. We'll do that again. There's nothing in there. It's not a magic trick, guys. I don't quite see how it works. But
do you know what a Doppler? You know when you listen to a train?
Yes.
And as the train comes past, it's close, and then the sound changes as it goes away from you.
Yeah.
Well, you can use that technology can be used to actually measure flow, because as you're putting signals into any sort of liquid or whatever,
right,
as it's the rate at which it's moving will give you a different signal coming back. Okay.
I learned that all about the Doppler effect when I was in the Royal Navy. I was in anti-submarine warfare, and sonar was my thing. So we tracked and hopefully found submarines and reported them back, and we didn't blow any up. But so it's the same effect, isn't it?
So Micronics do quite a few meters that use the Doppler effect. Using ultrasonic waves, okay, right, but this actually uses microwaves,
right?
Okay, and what you have here is like a microwave wrapped around the wastewater pipe, okay.
So that's actually in there. Then.
That's in there. That's head and this sensor and so on is wrapped around here, and it's basically injecting a signal into the fluid that's going out. And according to the rate at which that fluid is moving and the level of it and so on, will actually give you a different reading.
That's very clever, isn't it?
Okay, yeah.
It's clever stuff.
And it means it's hands off. No hands in.
Yeah, we don't want to be doing too much of that, do we? No.
So that's how it works. And as I've said, then when these RAS units here, these have to be located within about 15 meters of the. So that will be in a water pit. You'll have a cable that will come out to.
Is this mains power? Is it?
It can either be solar powered, mains powered, or battery powered. Combination of solar and battery powered.
Right.
Okay, to actually get it out. But
what's the battery life on them?
Battery life on them?
Yeah.
Well, it's rechargeable.
Oh, wow.
Okay, so you don't have to worry about that basically.
Oh, so when it's
yeah, it'll either be recharged on the mains, or it'll be recharged on the solar powered.
Okay.
So one of those is actually topping it up as it's going along. Right. So that's really the wastewater meter for the gravity feed applications. As I said, Micronics business is flow metering of various sorts of monitoring, and mainly ultrasonic. So it's clamp-on or non-invasive metering of different types. As I've said, there are other meters. If you had, for instance, if that wasn't a gravity-fed sewer, if that was a pumped sewer, okay, or pumped waste, then that wouldn't be suitable.
Right.
Okay? This is for gravity feed, which is what most applications are. But you do, of course, have pumped feeds coming off processes and so on. In that situation, we have a clamp-on Doppler flow meter, which will go on the outside of the pipe.
All right.
So it just clamps onto the outside of the pipe, and that will actually measure the effluent or whatever's flowing through the pipe.
So what's the maximum flow that this will...
That will depend on the actual size of the meter.
Yeah.
But I'll have to check in a minute. Let me have a look here now. It's basically 200 litres per hour up to 20,000 litres per hour for a 4-inch.
That'll cover most situations, I would suggest. Yeah, absolutely. Yeah.
And in practical terms, it'll keep reading right down to about 3 millimetres in the bottom. Okay.
3 mil?
Yeah, 3 to 4 mil in the bottom. It'll keep reading down to. And this, of course, has all been tested under the MCerts certification and testing. Right. So as I said, if you had a pumped, then you would use a Doppler clamp-on. or you can in fact use a Doppler inserted one, but you then have the trade-off that you're possibly going to get contamination of the sensor. So this, as I said, I believe is a unique meter, the only one. If I'm wrong, then please phone in and tell Graham.
Well, that's what it's all about. Education.
But I believe it is.
Yeah.
And we think it's got fantastic scope going forward.
Yeah, it has, absolutely.
On the other hand, we have, if I could just show you some other things.
Do you want to put that? Should we put that
down for a second?
Yeah. That on there. Here's one we made earlier.
This is one we made. It's like Blue Peter, isn't it? It's like I don't know if we can pick that one up on the camera, but basically this is a clamp-on flow meter. Okay, so this is for clean water applications now. Now, potential areas for your water bill being wrong when you're talking about metering and monitoring. First of all, incoming, as you know as a consultant, there is the potential that the main incoming meter could be oversized, incorrectly sized, or whatever. Okay. So quite often you have to do meter verification to check that it is what it says it's actually reading.
Peak flows,
it is actually what is flowing.
Yeah.
So having to cut into the pipe and so on is obviously not something you want to do.
No.
All right. So what we have is we have a whole range of clamp-on products which will actually clamp onto the outside of the actual pipe coming in or whatever. And within a matter of minutes, you can be up and reading. See what's
the
going on.
accuracy of these guys then?
These are actually 3%.
All right.
Okay, so this is the actual the action end, if you like. So you've got two ultrasonic sensors here. Okay, and this is where it goes onto the pipe. So if my arm's the pipe, it sort of goes on like that.
Yeah.
Okay.
Got it.
And so that is then strapped to the pipe, and this is the electronics end, which clicks in to the top. So basically, you adjust these according to the flow that you're expecting and the size of the pipe. Okay. And these can be provided for pipes ranging in size from 1 inch up to 6 inches.
Materials? Pipe materials?
Pipe materials, plastic,
Copper,
steel, cast iron.
Lead?
Not lead.
Not a lot of lead around.
Not lead.
It shouldn't be in there, guys.
But basically, there aren't many applications we come across we can't do with this, to actually achieve it. Now, that's a good cost-effective way to, as I say, check the verification of an incoming meter to make sure your meter coming in is right. The other thing, of course, is that when we're looking at maybe some bigger application sites, quite often you need to find out what's flowing where. You know how much water's coming into the site, but where is that water being used on the site? And so that you can do a map, if you like, of the site and its consumption. Now, breaking into the pipe work and actually putting in new meters means you have to drain down the system, cut the pipe, put in flanges or whatever, fit in a meter, etc., etc. So you get disruptions in processes and so on and so forth. In contrast to that, you can come in and actually physically put this on and get this up and running. Okay.
Where do these little boys go then?
Well, this is a heat meter application of it at the back, but this can be used just as a water meter if you want to. If you wanted heat meter, then these are heat meter sensors. So,
factory or any application really, where you want to identify water going into a specific process.
Exactly.
Wow.
Exactly. So you can then say, in the same way as you might have, for instance, energy consultants might do an energy map. Yeah. You can actually do a water map for a large industrial site or a large process, large campus application.
We had a call from a company recently in down south who £150,000 a year wastewater bill, and at certain times of the night the water flow would go up on the night shift, and he's looking at something like this, but I said that you need to do a survey first so we can look at the pipe work. That's still in abeyance, but basically then we figured that if we can identify which process that's going into, then we can get hold of those guys who are operating that process. We think what's probably happening is that on a night shift someone's probably got a process going, they walked away, gone out to have a smoke or whatever and a cup of tea, and might even be getting his head down, I don't know, and then coming back and losing, I think it's about 1,000 cubic meters a week that's going adrift, increase since they've got this night shift going. So they really need to drill down and identify that.
Yes.
And so that's a really good way, really, rather than, it's a quick way.
Absolutely,
isn't it?
absolutely. So using this sort of technology, as I say, we've got two versions really. We have portable instruments, and we have these is like a fixed instrument. Okay, the portable instrument we'll use to go in and find out temporarily what's going on.
Yeah.
Okay.
Yeah.
But then you might think that having done the initial investigation of the site and mapped where it's going, because things change over time, you might want to put in a permanent sort of clamp on just to do sub-metering of certain areas on an ongoing basis, so that as you're looking at the site, you're looking at it dynamically now. You're looking at the water coming in, you're looking at the sub-metering water usage across the site on various processes and so on, and at the same time you're looking at the wastewater meter.
So what wastes do you supply these? You do them on a lease, a purchase, rental?
It's normally an outright purchase,
Yeah.
But you can also rent the kit as well.
That's good, yeah.
So if you, particularly the portable instruments, and quite often what we find is that people rent the units
And then they want to keep
and they think, well, this is really good. I think we need to buy one of these, which is
Not a free trial, folks.
Yeah, but we also have a try before you buy scheme as well.
Yeah.
That if people are having trouble with the capex or whatever, but they feel that they really do need to try some out, then we'll work with them. See how they
Fine.
go.
If your water bill's 50 grand, 100 grand a year,
Yeah.
like I say, if you can't measure it,
No. Yeah.
then you can't reduce it, can you? So
Yeah.
that's fantastic.
Okay.
Yeah.
So that's the business we're in. Micronics has been established for over 30 years, believe it or not.
I first came across Micronics. I'm glad you said that. Ted Farnan.
Ted Farnan is still around.
well.
Yes, he's our chairman, Ted Farnan.
I remember this, and I'm not embarrassed about it, so I will admit it. But many years ago, I used to go to an exhibition called NEMEX, National Energy Managers Exhibition, in the Midlands.
Yes.
And all the energy managers and utility managers used to descend on this place and talk about energy management, water management.
Absolutely.
And I came across this,
Yes.
and I said, you won't go far with that. And look at it today. I stand corrected, of course,
Yeah.
and it's a pretty reputable firm.
So yeah, we're as I said, the longest established UK
absolutely.
manufacturer.
Yeah.
So all developed in the UK, built
Yeah.
in Britain.
That's fantastic.
So that's good news. As
Well-
is in fact the wastewater meter, which is another good thing.
Right, fantastic.
Which with Brexit is probably a good thing.
Brexit. And on that note, Dave Leigh, Marketing Director of Micronics, we'll call it a day.
Okay, thank you very much for the
indeed.
opportunity.
Cheers, thank you.
Thanks.